Welcome to Vagdevi College of Engineering, Compiler Design Lab, BTech 3rd year first sem, Department of Computer Science and Engineering. Prepared by M. Shidisha, Assistant Professor, Department of CSE. Students, here we are going to see about Week 5 program. In the Week 5, we are going to see the Predictive Parser. Before going to Predictive Parser, let us see what is a top-down parsing technique. So here we are going to have two types of parsing techniques, top-down parsing technique and the bottom-up parsing technique. In the top-down parsing technique, we are going to have a recursive descent parser. Under the recursive descent parser, we have a backtracking and the non-backtracking technique. So today our week 5 is all about the predictive parser. Under non-backtracking, we are going to have a predictive parser and which is also called as an LL parser. The LL parser, predictive parser is LL parser and the predictive parser comes under the non-backtracking technique. What is a predictive parser? It is a recursive descent parser which has a capability to predict which production is to be used to replace the input string. So, the given grammar and the given string, we are going to know that whether the string is acceptable by the given grammar or not is going to be predicted by the predictive parser. The goal of predictive parsing is to construct a top-down parser that never backtracks. The predictive parsing itself, we said that it is from non-backtracking technique. So, here the goal of predictive parsing is to construct a top-down parser which never backtracks. To parse a string and to check whether the given grammar is a LL1 grammar or not and the string is a predictive parser string or not to be known. So, in order to know all this, first we need to know the prerequisites to parse a string. So, how to parse a string is known if you are very familiar with all these prerequisites. The prerequisites are: eliminate the left recursion for the given grammar if needed. So, if the grammar has any left recursion, that particular left recursion should be eliminated. So, what is a left recursion? How to eliminate the left recursion is given in this link. Second point, perform left factoring if needed. For the given grammar, if it is having any left factoring, we need to perform a left factoring on that particular grammar. So, how to do a left factoring? What is a left factoring is given in this link. Next, third point is construct first and follow functions for the given grammar. For every grammar, we need to construct a first and follow functions. What is the first function and what is the follow functions? How to construct a first and follow functions is given in this link. Now the last thing is construct a predictive parts table for the grammar. And how to construct a predictive parts table is given in this link. To construct a predictive parts table, we need the first and follow functions. To construct the first and follow functions, we need to have the grammar as a eliminated left recursion grammar and the left factoring grammar. So, students, each and every point is dependent on its previous thing. So, for that sake, we said that the prerequisites should be learned prior. Then only we can parse a string. Here it is an algorithm for predictive parser to parse a string. Before going to an algorithm, let us see the structure of a predictive parser. So here is a predictive parsing program to parse a string and to know the output whether it is a string is going to accept or not. So for this predictive parser, what we need? The input should be in a string and the stack contains a grammar and a parsing table. The parsing table here is called as a capital M. So to parse a string, we need to have what is a string, what type of grammar and the table. Everything is to be known. In the beginning, the pushdown stack holds a start symbol of the grammar J. So the stack contains the first symbol as a start symbol into the stack. Second point, at each step, a symbol X is popped from the stack. So already we said that the stack contains the grammar symbols. If the grammar symbol X is a terminal, then it is matched with a look ahead, and the look ahead is advanced one step. If X is a terminal, it is going to match with this look ahead and it is going to increase. If X is a non-terminal symbol, then using the parsing table, a production is chosen and its right hand side is pushed onto the stack. In our grammar, we are going to have productions. The production consists of left side and the right hand side. The left side are the non-terminals and the right hand side are the terminals and the non-terminals. So whenever if the stack contains the X as a non-terminal to be popped, so at that time it is going to be depend on the parsing table. So in the parsing table, if there is a production, that production is to be chosen and its right hand side is pushed on. Students, you know that how to open the program. Since it is in a Predictive Parser, we are writing in a C language. So go to files, go to new and click on to a C or C++. And the next again go to file, go to open, and my program of Predictive Parser is in the programs folder. So Predictive Parser, open this code. So now here I have taken a 3 header files, stdio.h, string.h and the ctype.h, 3 header files, and now our program is to have a predictive string to be passed, and string whether to check the string is accepted by the grammar or not. So the grammar is, here we have taken a grammar called as, here I am writing the grammar, the first line itself. E tends to T dash, E dash tends to plus T dash, T tends to FT dash, T dash tends to star FT dash. So we have to write a slash epsilon also, slash epsilon, E tends to T dash, E dash tends to plus T dash, slash epsilon. The last one is F tends to E, and the A is my terminal symbol. This is the grammar. For this grammar, first the left hand side all are the non-terminals. For these non-terminals we need to write our functions. Void E, void T, void E prime. Instead of E dash I am taking it as an E prime, and the T dash it's a T prime, and the F is another non-terminal, void F. For all the non-terminals we are going to write the functions. So now let us see what these functions have consist of. E, void E. So here it's the part where I have written for the E, void E tends to T dash. So that is our grammar production is E tends to T dash. So I have opened my function called as E function, which consists of a T, again the function, and the E dash as another function, to call the E dash as another function, T dash. Now the next second production is E dash tends to plus T dash slash epsilon. So for this again now I have taken a function name called as void E prime. So now let us see what this function consists of. So what is the right hand side? Plus T dash slash epsilon. So here void E dash tends to plus T dash. So the input symbol is a plus, is a terminal symbol. If the given sentence, the given input has a plus as an input symbol, the terminal symbol, we need to increment the position. Else So after incrementing the position, the next one is plus t e dash. Again t function, again e dash function. So by e dash tends to plus t e dash. And the next one is the third production, t tends to ft dash. So we need to write in a t function, void t. Then let us see what we had in the void t. T tends to ft dash. So here void t is a function. We call the f function. We also call the t dash function. T tends to ft dash function. And the next fourth function is, the fourth production is t dash tends to star ft dash slash epsilon. So now we need to write the function for this t dash. The t dash refers to an t prime. What t prime? Now what we had in this t prime? Star ft dash slash epsilon to be written. So here, if our input symbol is an asterisk, it is a terminal symbol, then increment the position of the string, and the next ft dash. Call the f function, call the t dash function. And the last one is the f tends to e slash a. F tends to e slash a. So for this, here we written a f function as, within f tends to e, right hand side e is a non-terminal which is again placed in between the terminal symbol called as open and close parenthesis. And also we had another production called as f tends to a. So if my f is an any alphanumeric, it is an input is an any alphanumeric symbol, then increment the sentence, increase the position of the character. Else if the given string is an open parenthesis, also we need to increase. After increasing, now we had an f tends to e. E is a function which is enclosed within the open and close. After calling the e function, now we need to close the parenthesis. After closing, again we can increase our input sentence. If not, else it is an error. If it is not an alphanumeric, also it is an error. If not, it is an any f tends to e is also not there, then we can then also you are going to have an error message. Now we have taken the each and every production. Now let us see what to be written in the main function. What to be written in the main function. Here I am declaring two variables called as I and error as equals to 0. Already the variables have been declared as an integer variable. I am assigning the values as 0 to an I and error, and the input string of an array called as 10 size I have taken. You can take any sort of size. Printf enter an arithmetic expression. So my input string, so here I have taken as an a. So example, I am giving the input string, the arithmetic expression may be in the form of a plus a star a. Gets this input by using a getters function, and now the start symbol in your production, in your grammar, the left side, the first symbol is a start symbol. First you call the start symbol. So in our grammar, I had a start symbol as e. So this e is a start symbol which we have called. So e is a function which is going to call the function, and then it is going to process the remaining all the functions. If the string length of input is equals to I and error is equals to 0, then the printf is going, so it is going to accept the string as an accepted. Else it is going to have an rejected. It will be rejected. So let us see how it is going to compile and how it is going to the compile. See, no errors. The next execute, that is called as run. Enter an arithmetic expression. So here I am entering an expression called as a plus a star a. So let us take in a terminal symbols itself, a plus a star a. String is accepted. Press any other key to continue. Now again, once again, let us see. Compile. run. Now I am giving a sentence as expression, string as a plus into a. It is rejected. Why? Because here an operator should be present in between the operands, but here a two operators plus and asterisk, that is plus symbol and the multiplication symbol, we are placing in between the two operands, but now a single operator should present in between the two operands. Here it is this expression is not a correct expression to evaluate, so for that sake it is rejected. Design a predictive parser of the given string A, from the grammar S tends to ASB / epsilon. So this is the next exercise, the case study where the students you need to do it. So this is a string, input string, and this is the grammar. From this grammar you need to derive the string whether it is going to accept or not. And under this epsilon you can use any other special character. Thank you.